Okay guys, so I'm working my next problem that I have. Now this one again had a little formatting issue. I guess I didn't pay well enough attention. But, so there's your question. Just focus on the question in the first line and a half. Okay, take a picture. So we want to find the standard molar enthalpy of formation for FeCl2 using these reactions. Now again, in the spacing, the second reaction that I have here was kind of split between the two lines. And then it was a multiple choice question that I just stole this from, so it had some answers on it. Don't worry about that, okay? Here are the two reactions that are given. It gave us the delta H's for both of those, okay? So for this reaction, the delta H is negative 57.7. For the second reaction, the delta H is negative 399.5. And it wants me to find the delta H for the reaction of the formation of FeCl2. So, if I wanted to form FeCl2, what reaction would I have to do? Well, I would have to take some iron. I would have to add Cl2, and I want to make FeCl2. Okay, so from the elements, I'm making FeCl2. Now, when I do that, I of course have to look and make sure everything balances. FeCl2 is the compound I'm trying to make. It does have 1 iron and 2 chlorines in it, so that works out very nicely. And my goal here, I want to know what is this delta H value. Okay? Now, this is an example of Hess's law. They gave me 2 reactions with their delta H's. They asked me for the delta H of another reaction that I had to write for myself. But I should be able to use these numbers to find that. Okay? So, what I would do, I would look at each reaction, look for a compound that each reaction contributes to the one I want, and then decide how I need to adjust these. Okay? So if I look at the first reaction, what compound in this reaction do I need in my final reaction? And the answer is chlorine is needed, but see how I have chlorine in 2 different places? I don't really want to look at it right away. I'll deal with it at the end of the problem if I have to. Okay? I'm going to look at FeCl2. I need FeCl2 in my final reaction, but what I notice is FeCl2 is on the left side of this reaction. I want it to be on the right. This is my goal. I want this reaction. FeCl2 needs to be on the right-hand side, so that means that this first reaction, I'm going to have to reverse it. So if I reverse that reaction, then what's going to happen is it's going to change the sign of delta H. So I'm going to multiply negative times negative 57.7, which would end up being a positive 57.7. Okay? So that reaction, if it works out right, by reversing it, it's going to give me the FeCl2 that I need on the right. Okay? I look at the second reaction. The unique atom or molecule I have there is iron. I have 1 iron molecule or atom on the left side. In my final goal reaction, I want 1 iron on the left side. So this reaction, I can actually leave it as it is. This reaction is good. Check. All right? So in theory, if I've planned properly, I should be able to turn the first reaction around, add it to the second reaction, cancel things out on both sides, and it should give me this. If that works, then my delta H should be the opposite of this delta H plus this delta H will give me the final. Okay, now you should always check your work. So just to be sure, in the bottom, I'm going to say I have 1/2 of Cl2 plus FeCl2. Oh wait, no, actually, I was about to mess up. The first reaction has to be reversed. So I'm going to have FeCl3 on the left side. From there, plus Fe from here, plus 3/2 Cl2. Okay, so that's the reactants here, and then this one, once I switch it, this will be the reactant over there. Okay, products. I'm going to have these on that side, so that's going to be my 1/2 Cl2 plus my FeCl2 plus the product here will be FeCl3. Okay, so now I've got all the reactants from the way I rearranged. All the reactants are over here, all the products are over here. I can cancel out FeCl3 on both sides. Cancel that out on both. And then the chlorine on both sides, I can take away the smaller one. So half Cl2 is the smaller one. I can take that one away, and I can subtract a half from over here. If I did 3 halves minus 1 half, that's going to give me 1 whole Cl2 molecule as my final. So I'm going to have my Fe, I'm going to have my whole Cl2, and I'm going to have my FeCl2. Those are the 3 things I needed in my reaction. So that means that the planning I did earlier should work. So now I should be able to add my numbers. Give me positive 57.7 plus negative 399.5. And I got the answer should be negative 341.8. And that is kilojoules. I just ran out of room. Okay? So that's the end of that problem. All right. So that brings us to our next problem. It's the one on top right there. Take a picture. All right, so I'm eating a bag of chips, a big bag of chips. If it has 77 grams of fat and 122 grams of carbohydrates, how many calories would you be consuming if you ate the whole bag? Okay, so the word calorie, if you notice, had a capital C. Nutritional calories technically are kilocalories. That's just something you should be aware of. Not really going to affect what we do in the problem, but it is important when you're talking about nutritional calories, you should write it with a capital C every time. Okay. Now, the 8-ounce bag doesn't really matter in terms of that's not going to affect our calculation either. We know that we have 77 grams of fat, and we know that we have 122 grams of carbs, carbohydrates, which are sugars or starches. Okay, now both of these molecules are molecules that we can get energy from food. If our body burns fat, we get 9 nutritional calories from each gram of fat that we burn. So I'm going to use that as a conversion unit. It's going to be 9 calories per 1 gram. So if I multiply 9 times 77, that's going to give me 693 calories. All right, then the carbs, for those you get 4 calories per gram. I do think that is something that you should know. The fuel value for foods, 9 calories per gram for fat, 4 for carbohydrates, and then if we had protein, you'd also have 4